This is a convolution and this is a First, let's start with a standard convolution. Let's say we have an input image of 32 by 32 by 3 and we are going to do a 5 by 5 convolution with no padding and a stereo 1. Since our input image has a default 3, our kernel must have a default 3 as well. So 5 times 5 times 3 will give us 75. This means that we will perform a scalar matrix multiplication on every 75 pixels every time the kernel moves, giving out one number every time. So our 32 by 32 by 3 image will become a 28 by 28 by 1 image. Check the previous dimensionality video to understand how to calculate the output shape. But basically what I'm doing here is 32 minus 5 plus 1, since I don't have padding and I have a stereo 1. This will result in 28. And this is how a normal convolution works. If we want a different output shape, let's say a 28 by 28 by 64 with 64 channels, then we must to create 64 different kernels of 5 by 5 by 3. So we will have 64 of these kernels. This will result on 64 images of 28 by 28 by 1. After that, we will stack them up together to create the 28 by 28 by 64 image. And that is all. So how many multiplications did the computer have to do? Well, to calculate that, we will multiply 64, which is the number of kernels, times 5 times 5 times 3, which is the dimensions, and this kernel moved 28 by 28 times. So we're multiplying 64 times 5 times 5 times 3 times 28 by times 28. This will result in 3,763,200 multiplications. Now a separable convolution. This splits the process in two parts, a Depthwise convolution and a pointwise convolution. Let's start with the part 1. We have our input image of 32 by 32 by 3 and we will perform a 5 by 5 convolution with no padding and stereo 1, same as before. Instead of having a kernel with dimensions of 5 by 5 by 3, we will have 3 kernels of 5 by 5 by 1. Each kernel iterates in one channel of the image. So this will result in an image of 28 by 28 by 3. Each kernel output is 28 by 28 by 1. We have 3 kernels, we stack them up together, and we get a 28 by 28 by 3 image. So after that, we will perform a pointwise convolution. The pointwise convolution is a 1 by 1 kernel with the same depth as the input. In this case, it is 3. So this will return a 28 by 28 by 1 image. We want a depth of 64, so we need 64 kernels of 1 by 1 by 3. In this way, we will get 64 images 28 by 28 by 1. We stand them up together and we will get our final shape of 28 by 28 by 64. So in this case, how many multiplications did the computer have to do? Well, we have 3 kernels of 5 by 5 by 1, so 3 times 5 times 5 times 1. That move 28 by 28 times, so times 28 times 28. This will result in 58,800 multiplications. Then we have the pointwise convolution. We have 64 kernels on 1 by 1 by 3. So 64 times 1 times 1 times 3. That move 28 by 28 times. So times 28 times 28. This will give us 150,528 multiplications. We sum these two values to get the final result, and we get 209,328 multiplications. As you can notice, this is a very small value compared with the previous one. So these are the number of multiplications. As you can see, the separable convolution is more efficient. This is because in the normal convolution, we transform the image 64 times, and in the separable convolution, we transform the image only once in the Depthwise convolution, and then elongate it 64 times, instead of transforming it over and over again. This is the key part of our mobile net architecture, which will be the next video of this channel. My name is Alberto, and subscribe for more.